There we go. Recording. We start Unit 2 today. And that's even though I have students, you know, that the dog, let's see, the dog died, the cat's sick, my computer blew up, my computer went over here and did this. We're on Unit 2. All right, I'm not going to listen to all that. Okay, Unit 2, even though we did have people not turn in homework. Yep. We had people get zeros on homework, and we had people that didn't do the test or haven't done the test yet. I guess they're going to wait till the last minute. So here we go. So I hope y'all got some time to take the test. I hope, when's the test due? Anybody know? Is it already due or what?
Due tonight, right?
I'm sorry, what?
Due tonight, right?
It's due tonight. So those of you that's going to come to me with all kinds of excuses, don't waste your breath. You've had a week, and this is the 6th week. You've had 5 weeks to do your homework, so don't. I appreciate if you just don't, because that'll just make me mad. Unit 2. Unit 2, patterns, which we call correlation. And causality, which is cause and effect. And I don't know if it's affect or effect. I've tried to figure that out for the last 20 years, and I still haven't figured it out. So I think it's effect, cause and effect, I think. All right. Is it effect or effect? Because effect is when something is affected, I thought. Effect is like when something happens. So I don't know. And we also going to talk about slope and how to calculate slope and the point slope equation. Now, this is just the first part of Unit 2. This is 4.1 and 4.2. Now, I'm just going to go through and teach it all in one little session, because it's only 2 sections, and you're talking about 20% of the test. 20% of the Unit 2 test. So we need to get into Chapter 5 as soon as possible, just like we got into Chapter 3, and I spent time in Chapter 3 going over the stuff that you need to know. I think you can say my test is fair, and I didn't try to hurt anybody, I don't think. I think the grades were kind of high. There should be, because the test is easier than the homework, and that's the way I meant it out to be. So I'll do the same thing with Unit 2. 80% of your test is going to be from Chapter 5. 20% is going to come from 4.1 and 4.2. Now, one of the things that we talk about in Chapter 4 is one of these guys. Does anybody know the term for this? What is the term for this type of graph? It's called a
scatter plot.
Scatter plot. Good job. And when I do anything on Excel, I usually do a scatter plot. Make sure you know a scatter plot. This is very important for standardized tests as well as my test. Make sure you can see a pattern. This line here that I'm drawing is called the line of best fit, line of regression. It has an R factor. That R factor is between +1 and -1. That's called the R factor, or the correlation coefficient. Remember, I told you that correlation is equal to pattern. So I see a pattern with these dots. And this is what we call a positive correlation. Now, why did I call it a positive correlation? Anybody know? Because it follows along a positive what? Slope. Correlation and slope are related only by the sign. If you have a positive correlation, that means you're going to have a positive slope. If you have a negative slope, that means you're going to have a negative correlation. The only difference between correlation and slope, correlation goes between 1 and -1. Slope can be any number. So write that down because that's very important. I'm even going to take a highlighter and highlight that. Slope has a relationship with correlation. And that relationship is positive and negative only. Correlation goes between -1 and +1. Slope can be any what? Any number. You can have a slope of 1,000. You can have a slope of -10. You can have a slope of -1/2. But the correlation has to be between -1 and 1. So why am I telling you all this about correlation? Because correlation is the first thing we learn in 4.1 and 4.2. And you should be able to see a pattern. And here are the 3 patterns that you need to look for. I just showed you the positive correlation. So what do you think the second one's going to be? Come on, put that critical thinking to work. Negative correlation. And you see a pattern there that looks like this. Now, I am going to show you how to get this line with the calculator and the Excel spreadsheet. I do not, make sure you remember this, I do not want you to find it by hand. It's too tedious. So this is negative correlation. And then what do you think the third one is?
No correlation.
Exactly. Mr. Butcher, how are you this morning?
I'm doing good. What about you, sir?
I can't complain. I can always rely on Mr. Butcher. He always comes in and talks. It may be 30 minutes into the class, but, you know, can always count on him. Those are your 3 correlations. You have a positive correlation, which means you have a positive slope. You have a negative correlation, which means you have a negative slope. And then you have 0 correlation or no correlation, none. And that's a slope of 0. Okay? Are all 3 of these standardized test questions and Hubert questions? Yes. You will see this on my test. You will see one of them. You may see all 3 of them. You probably see one question and it matches up the correlation to the graph. And each one is like 0.33. That'd be the kind of question I would put on the test. Okay? So does anybody have any questions about correlation? I will show you how to calculate it. I will show you how to get the R factor on the calculator and the Excel spreadsheet. And we'll do that in just a few minutes. But I like to get the definitions out of the way first. How many of you have ever seen, well, I don't know, it used to be, I used to ask this question and everybody had seen it. But now, since it's not a cartoon or a Marvel Comics movie, not many of y'all watch movies, but anyway, Matrix. Y'all remember the Matrix?
Yep.
Okay, so I figured I'd get at least one. Let's see, I can't spell restaurant. Matrix 2 restaurant scene. I cannot spell restaurant. That's one of those words I hate. There we go. And we're not going to do the whole, that's the Matrix. Causality, there it is right there. Now, we're not going to be able to show about the chocolate pie, okay? We're not going to be able to show that, okay? But anyway, there's the owner of the, and let me see if I turn it up. Okay, we ain't going to be able to show that one because he's perverting himself there, so we're not going to talk about that one. Let's see. Well, anyway, I'm not going to be able to find it unless I go to YouTube. In this scene, I misspelled it. In this scene, they walk in and they say, "We are looking for the key maker." And the owner of the restaurant, he talks French and he goes, "Oh, I knew what you were here for. Everything's cause and effect. Causality." And they go, there he is. We'll watch this. Can y'all handle it? Can y'all handle watching this without complaining to my department head? Okay, those two guys are creepy. Here it is. Cause and effect. Anyway, he says, "I drink too much wine, I have to pee. I drink too much wine, I have to pee." That is causality. Now, if you get offended by me saying that, that's fine. I didn't say it. He did. He says, "I drink too much wine. I love to drink French wine." And he says, "I drink too much wine. I have to pee." Cause and effect. That's causality. So you need to write that down. Causality, and write it down again. Causality is cause and effect. If you load down your car with luggage and 6 or 8 people, what's going to happen to your gas mileage?
It's gonna go up because you're using more gas, right?
Yes, the gas mileage, yeah, you're right. The gas mileage is going to go down because you're using more gas. I think that's what you were saying, Mr. Butcher. Okay, so
Yeah.
here's the cause and effect. I drink too much. I have to take a break. I load down my car. I have no gas mileage, or my gas mileage goes down. I don't know how to spell mileage. I think is the E in there? I think it's AGE. That don't look right. That looks like Milage. I can't spell mileage. Anyway, what's mileage? Does mileage have an E in it? Y'all ain't gonna tell me. Y'all just sit there with the Mr. King. He left. He drank too much wine.
It's MILEGAGE.
EAGE. Thank you.
Yeah.
I don't like words that have an E in there because I can't ever remember how to either drop it or, and I don't need English lessons, so don't tell me. All right, so this is cause and effect. Let me ask you a question. Let's say that I work at a movie theater. Dago Amstar 5 or Amstar 14 or whatever it's called. And I daggum work there part-time, and I take a class. I'm in Hubert's Math 120 class, and I got to turn in a project. Okay? So I say, well, you know what? A Nicolas Cage movie, Con Air, is on, and the ticket sales look like that. Everybody with me? And I find out, I put it in the computer. This is over a month's time. You ever seen the movie Con Air? Of course not. It's not Marvel Comics, and it's not a cartoon, so y'all haven't seen it. Anyway, I get an R factor of 0.85. Everybody with me? And then I go to the to the hospital, and I ask, how many people have died of suicide in the last month? And it looks something like this, with a correlation coefficient of 0.82. So I can actually say that Nicolas Cage movies cause people to kill themselves. True or false?
It's false, but I think it might be true.
Have you ever seen a Nicolas Cage movie? I'm sorry. Con Air was actually decent. It wasn't great, but it was decent. All right. But he's so out there floating. He's out there. He's floating. No, you can't do this. Okay. This is not possible. You can't just go out and match up two graphs and say, oh, well, this causes this. You can't do that. Okay, now we're going to write down a very important rule about causality right now. So I'm going to write it in red. So that means it's very important. Correlation does not always equal causality. But causality always what? Correlation does not always equal causality. And remember, Nicolas Cage movies do not make people commit suicide. All right? You can put two graphs side by side, and they can have correlations close to each other, but that doesn't mean that the cause and effect is there. But if you have something that you can prove is causality, does that mean there's going to be a correlation? Yes. So this is very important. Now, how do we find causality? Well, usually you can do it with your calculator or your Excel spreadsheet, and that's the way we're going to do it in here. So what I'm going to do is I'm going to go to the Excel spreadsheet, and we're going to do one, and that way you can see how to do it. So I want you to write down what I do in the Excel spreadsheet for those of you that didn't, that don't know how to use Excel. And then I'll show you how to do it on the calculator. So let's do some points. Let's go with 1, 2, 3, 5, 6, 8, 9, 12, 14, 15, 17, and 22. And then over here for the Y, we're going to do 2, 4, 5, 1, 3, 5, 8, 9, 6, 11, 10, and 8. So write those down because you're going to put them in your calculator. Go ahead and be putting them in your calculator. This is X or L1. And this is going to be Y or L2. Go ahead and type those in. And first, we're going to do it on the spreadsheet first, because I want you to see what you're actually wanting to get. And then we'll do it on the calculator so you'll know what you're looking for. I'll make it a little bit bigger for y'all. This is what I will ask you to do on a test. I hope this turns out decent. All right, so what do? If you're using the Excel spreadsheet, you highlight the 2 rows. I'm sorry, the 2 columns. And then you go to Insert. And if you look, there's box plot, right? I'm sorry, scatter plot right there. You click on the little arrow, and there is the scatter plot. See it right there? And there is our scatter plot of those points. Now you need to be able to do that. I'm not even going to ask that you do it by hand. I want you to do it either with the calculator or with the Excel spreadsheet. Now, this is very important that you understand this. You take the cursor and you click on one of the dots. And then you right-click on the dot. So click on the dot, or you can just right-click. So I'm going to go to it, and I'm going to just right-click on one. See it automatically. If you click on it, then right-click, or you can right-click. And go to Add Trendline. Trendline is another word for regression line or line of best fit. Write that down. Trend line is equal to regression line or line of best fit. And there's your line. Now look over here and look at the choices you have. Exponential, linear, logarithmic, polynomial, which means quadratic, power, and moving average. Now, you don't have to worry about these because most of ours in here, I think 99% of them are going to be linear. And then you go down to the bottom, scroll down to the bottom, and you type in, you click on display equation and display the R factor. And it's over here. Let me get out of this and you'll see it. There it is. Now I'm going to move these over here so you can see it. And I'm going to highlight it. And I'm going to go up a little bit so you can see there. All right, now that's what you're going to be tested on. Now I need somebody, well, I'll do it. They don't give you R, they give you R squared. I don't want R squared, I want R. So you take 0.5917, 0.5917, and raise it to the 1/2 power. Or take the square root of it. Turn the calculator on first. 0.5917 raised to the 0.5 power. And that's your R. So write down your R is equal to 0.7692. That's what I'll ask you on the test. And I'll ask you for that equation also. All right. Does anybody have any questions on how to do it on the Excel spreadsheet? And we'll do it 5 or 6 times with homework and stuff like that. We're going to do it in class. I'm just showing you kind of an intro. You highlight your columns. You go to Insert. You go over to Charts and pick on the chart plot. And there it is. You right-click on one of the dots, add trend line, and go down and hit Display and Display. Then you take R and you raise it to the 0.5 power, take the square root of R squared, and that will give you R, which is your correlation coefficient. So our correlation coefficient on this, hold on a second. Our correlation coefficient on this guy is 0.8 or 0.77, which is pretty good. So there is a correlation. Now, if this was people in the car and gas mileage, that would not be correct because you don't increase your gas mileage with putting people in the car. All right, so that would be incorrect. It'd have to be something else like, I don't know. I have to think about it. Anyway, that's how you do it. Now let's do it in the calculator. Go to Stat, Edit, and let's type in 1, 2, 3, 5, 6, 8, 9, 12, 14, 15, 17, and 22. Everybody with me? Now 2, 4, 5, 1, 3, 5, 8, 9, 6, 11, 10, and 8. Everybody good? Now I want you to hit Stat, go to Calculate, and go to Linear Regression, number 4. And it automatically reads L1 and L2, so you don't have to do that. Just go down to Calculate, hit Enter, and there it is. And if you notice, let me pull up my handy-dandy whiteboard. And if you notice right here, they give you y is equal to mx plus b. That's what you learned in high school and junior high school. That's the standard form of a straight line. M is equal to 0.3768421053. And B is equal to 2.42, and R is equal to 0.7692257262, whatever. And you would plug that in, and your final answer would be y is equal to 0.3768 x plus 2.42 with an R factor or an R correlation coefficient of 0.7692. And that is the same thing that we got here because you got to take the square root of 0.5917. Okay, who's got a question? That, you're talking about two test questions right there. One, can you plot it? Now I'm going to show you how to plot it now. I plotted it on the Excel spreadsheet. And the second type question is the equation of the line and the R correlation coefficient. Now, on your calculator, how do you graph the points? Well, look at the top of the y equals and you see a blue stat plot. So you hit second, y is equal. Click on the first one. That's the one everybody uses. Hit enter. Turn it on. You hit enter. It's already defaulted to scatter plot. And it already reads L1 and L2. So all you got to hit is graph. Now I've got something in mind. Hit zoom. And go to, I think it's stat. Number 9. There is my points. Now I'm going to go in and put in my line. Y is equal to 0.3768x plus 2.42. Hold on, let me get rid of this other stuff. I hate these calculators. You have to be careful because if you go too far, it'll take out your whole equation. I think that's it. And hit graph. Look at there. And that's what your graph looks like. So the 3 questions you should be able to do. 1, you should be able to do a scatter plot with technology. Okay, that's number 1 for the test. Number 2, you should be able to find the equation of the line and the R factor with technology. This is called the correlation coefficient. Correlation coefficient with tech. And 3, well, that's pretty much it. Because if you can do those 2, if you can do a scatter, 3 is make sure you can plot the line. So those are the 3 things that I'm going to ask you to do out of 4.1 and 4.2. Now I need to show you one more thing before we conclude 4.1 and 4.2, and that is we got to bring back our old buddy, the slope and the point slope equation. Y is equal to mx plus b, that's the standard form of a line. And m is equal to delta y over delta x, which means y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the point slope equation, y minus y sub 1 is equal to m times x minus x sub 1. Does everybody remember those guys? Yeah, we remember them, Hubert. Good. Glad you're interacting. All right, so I'm going to give you 2 points. Let's go with something simple. 2, 2 and 8, 6. All right, I want you to give me the equation for these 2 points. Give me the equation for the line that goes through these 2 points. Go ahead and do that. You got a couple of minutes. And Miss Reed is here. So I can count her off of the... Hold on, I'm trying to get somewhere else right quick. There we go. 2, 2, 8, and 6. Two, 2, 8, and 6. There goes Miss Reed. You are here. And I don't have to do anything else. Everybody is here this week. Good. Attendance tracker. I would say Miss Gravina is sitting in the 2nd story lobby right over there next to the hallway near AC 202.
Yeah, I am.
Y'all are impressed, aren't you? All right, here we go. 2, 2, 8, and 6. 2, 2, 8, and 6. See, I done offended Mr. King again. He left. There he is. All right. X of 1, Y sub 1, X of 2, Y sub 2. And I'm going to find the slope first. M is equal to Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. Now, I'm going to show you a trick I learned in the war. If you come up to me 20 years from now, and I'm in my wheelchair slobbering all over myself, and you ask me to do the slope, I'm going to do this right here, even though you come 20 years from now, or if you come into my office tomorrow, or if you ask me to have virtual office hours in a week, I'm going to do this. I have several degrees. I have most of my teeth, and I have running water in my house. Okay? I still use those parentheses. Do you know why I use those parentheses? Can anybody tell me why? Because of fractions and negatives. That's why. So you got whole numbers here. Whole numbers are okay. They're easy. But are they always going to be whole numbers? Hell to the no. So you need to use these parentheses. I don't care how smart you think you are. You're going to get caught if you don't use those parentheses. And don't cry when you have a negative slope and it's supposed to be positive because you didn't use parentheses. Okay, so 6 and 2, 8 and 2. 6 minus 2 is 4. And 8 minus 2 is what? 6, and that is 2/3. Did everybody get 2/3? So M is equal to 2/3. And I'm going to pick a point. Which point do you think I'm going to pick?
The first one.
Which point do you think I'm going to pick?
The first one.
Why am I going to pick this one?
Because
KISS method.
Easier.
What's the KISS method? Keep it simple. Always go with the smallest numbers. Always. Unless you just like pain More power to you. All right. No, I don't want to say pain because sometimes pain can be good. But like you ever been electrocuted before? Nobody's ever been electrocuted. Oh my gosh, I've been electrocuted so many
Yes,
times.
I have.
Oh, how do you feel afterwards?
Shocking.
It actually makes your body feel good. I'm not talking about right after. I'm talking about like 5 or 10 minutes later. Your body actually feels better after you've been electrocuted. I mean, I'm not talking about hit by lightning, okay? That's not being electrocuted. That's freaking getting hit by lightning. I'm talking about peeing on an electric fence or touching an electric fence or working with electricity and you forgot to turn the switch off. You ever been electrocuted? After you've been electrocuted, your body feels kind of rejuvenated. Okay, I'll shut up.
I've been.
Why? What?
I said I've been worse than electrocuted.
What have you been? You ain't been run over by a train or anything, have you?
I've been shot.
Oh my gosh, how did you get shot?
My gun went off and it hit me in the foot, and they had to amputate half of my foot because it did so much damage.
You know what? They almost had to amputate my foot. And guns kill. That gun has a mind of its own. It will try to kill you, so you better watch it because guns kill people.
The worst
All
part
right.
was it was at school.
Oh my gosh, that's awful.
I know.
I almost had my foot amputated because it got caught in a bush hog,
I
and
think
it sliced half of it open. And the doctor said you might have to come back in about 6 weeks, and you may have to get this foot amputated. But it didn't. So I hate that for you. What caliber gun was it?
it was a shotgun.
Yeah, that would do it.
I think
Yeah.
it was a buckshot because they all exploded in my foot like the pellets did.
Well, that goes to show you that you have to be careful. How old were you?
18. It was like the biggest freak accident that ever happened to. Like I didn't shoot myself in the foot. Like my gun went off. Does that make sense? Because I was on the shooting team at school.
Oh, okay.
And
Well, they can happen. I mean,
yeah.
Usually, and I will say this till the day that I die, guns don't kill people. People kill people. And when a gun goes off, usually it's because of operator error. Very rarely do you see a gun go off sitting on the table.
Yeah.
Yeah.
Unless it malfunctions. But I think something was wrong with mine.
Well, I hate that for you.
Because that was the first time I'd
But you know what? I'm not trying to make it all about me or anything, but when I had my foot cut by the bush hog and it was a mess, I could hardly even feel it. I didn't feel any pain.
Me either.
So that's interesting how your body takes care of stuff like that. All right. So anyway, y, and I hate that happened to you. Y minus y sub 1 is 2 equals m times x minus x sub 1. And now you're going to simplify that. So I'm going to take this right here and I'm going to draw a line. This is step 1, finding the slope. And this is step 2, plugging and chugging into the point slope equation. And that's going to give you y minus 2 is equal to 2/3 x minus 4/3. And y is equal to 2/3 x. What is 4/3 plus 6/3? Negative 4/3 plus 6/3 is 2/3, isn't it? That should be your answer. And no, you should not ask me where did I get the 2/3. Well, you got to bring this 2 over and you got to have a common denominator. So what is 2 in relation to thirds? 6/3, Hubert. That's right. So this negative 2 that I just colored blue is going to come over here as 6/3. This is the fourth thing that I will test you on in 4.1 and 4.2. So let's write that down. Number 4. I will test you on y or m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and y minus y sub 1 is equal to m times x minus x sub 1. So those are the 4 things that I'm going to test you on. I'll let you, well, you got that on this page anyway. I'll let you finish writing that one down. Does anybody have any questions on what we did here? What high school did you go to that you shot yourself trying to see your name?
Pendleton.
Oh, you were at Pendleton? Good gracious.
Yeah, I was here.
I'm surprised we didn't hear about that.
It was on the news.
Oh, it was? Well, I don't watch local news, so. But like I said, I hate that happened to you.
Me too. Yeah, it was on Anderson Independent. If you look it up, it says.
Yeah, I like I said, I don't. One of the reasons I don't watch local news is because local news thrives on drama, and that's why I don't like anything to do with drama. That's why I stay on the farm. The more people you hang around, the more drama you have. So if you hang around on the farm, you don't have much drama. Right, Mr. King? I bet Mr. King's drama hound, didn't he?
Oh, yeah.
What? What did that
Mr. King, I'm just making sure you don't go to sleep when you lay back there in your bed. I just want to make sure you're not going to sleep.
Sir.
Huh?
No, sir. I try not to.
I know you can't go to sleep in my class. You might miss something. You never know what I'm going to say, especially with cocaine. I can't believe you thought I said that. Was not the way I said that. Y'all take stuff out of context.
There was context behind it. It was just funny. It kind of caught me off guard.
Well, listen, it caught us off guard when they had to police escort that guy out on the second floor. I mean, that was. You just don't do stuff like that. I mean, but like I say, this generation now, they want to start a revolution and can't make a ham sandwich. They don't have much sense. This was a young guy. I mean, All right, so let's go to the slideshow here. And this is chapter 4. We're just going to look at some questions they may ask. And I will tell you if it's a test question or not. All right, these are just some examples that they put in the PowerPoints. And I'm just going to let you know if it is okay, there is a possible test question right there. Now, of course, if you want to type that in your calculator right quick, I'll let you do that. So go ahead and type that in your calculator. This is your X. This is your Y. Go ahead. I'm going to do it on the Excel spreadsheet. Well, I better do it on the calculator too. Go ahead and type that in your calculator. Yeah, you can tell how smart your teacher is if they've been there a long time. That means they're pretty smart. But if you go one semester and the teacher's like gone, then you know that teacher wasn't very smart. Now I'm going to pull up my handy dandy calculator and my spreadsheet. And since I do things for y'all all the time, I guess I'll do it here. Oh, y'all are just spoiled. All right, second, or let's say stat, edit. And that's going to be 35, 50, 75, 95, 120. Oops, 120. Y'all watch as I type these in, make sure I type them in right. 145, 155, 160, 175, 185, and 190. And then I'm going to go over to the second column. And 5.88, 5.99, 6.74, 6.1, 7.47, 6.93, 6.42, 7.97, 7.92, 7.62, 6.89, and 7.9. I think I got everything correct. Now, let's do a chart plot. So I'm going to go to second, stat plot. It's already on because we turned it on a while ago. And the only thing I got to do is hit graph because everything is already set. So hit graph. And don't worry about the line right now. It's not showing up, so I'm going to hit zoom 9 again. And there is my points. Or there are my points. Now I need to do a trend line. How do I do that? Well, I go to stat, calculate, and linear regression. Now I need somebody to write this down because I'm not going to write it down. I'm going to let y'all write it down. There you go. Write down the whole number. You don't need R squared. You just need R. So write down the M, the B, and the R. And the reason I refer to it as M is because you've been studying y is equal to mx plus b for the last 4 or 5 years in algebra. And why they change it in this class to A, I have no idea. So I just ignore the A and call it M. So that way you'll know. So write down the whole number so you'll have it and check it with your calculator. You should have the same numbers I have, unless I typed in a number wrong. But we'll see when I do it on the Excel spreadsheet. So that way we'll check our work. So write those numbers down if you don't have a calculator. And if you do have a calculator, check them and make sure they're the same numbers. Or if you're just not going to participate, just sit there. Like Mr. Butcher, he probably went back to sleep.
Yep, I'm knocked out.
That's why you drink too much. You need to lay off. You need to lay off that bourbon, Mr. Butcher. Wild nights. Notice he didn't say anything. He knows
as much as I like to drink bourbon, I'm probably pretty sure my mom would whoop me.
Well, I'm a bourbon drinker. I'm not, like I say, when I do drink, my kids make fun of me because I have a nice stocked bar cabinet, and they make fun of me because it never changes. I don't drink that much. But I have it, and I have it, when somebody comes over and wants a drink, that's why I have it. This thing called moderation, it's a good term, moderation. It's the opposite of extreme. These are people that drink like, I know a guy that you'd go to church at 9 o'clock in the morning and he'd smell like vodka, and he wasn't a diabetic. Ooh, he reeked. All right, here we go. And y'all will run into somebody like that. You'll be at work one day and you'll run into somebody and you're like, oh my God, it's only 9 o'clock in the morning. Yeah, it's pretty sad. if you hadn't already ran into somebody like that. And nobody's going to say anything. Okay. All right, let's go to try to make the class interesting by bashing on people, but y'all won't cooperate. So I know, Miss Owens, you run into people like that at work all the time, don't you, Miss Owens? She went back to sleep.
No, I only run into people that smell like they smoke a pack a day.
Oh my gosh. That's one of the reasons I don't use the elevator at the Anderson campus. Oh my gosh. You get on that elevator, you're going to come in behind somebody that smokes a pack of Marlboro Reds every hour.
Oh my
Oh
god.
my gosh.
I would rather
It's
smell
awful.
liquor than that crap. It's terrible.
Mm,
And you
it
can
is bad.
tell because it's usually like the older women that their faces are all wrinkled up and it's bad.
Miss Owens, you rough on them people. Woo! You rough. You wouldn't be good at customer service, I don't think. You better stay where you are. You talk about people. You like me. All right.
Too
So here
honest.
we go. 35, 50, 75, 95, 120, 130, 145, 155, 160, 175, 185, and 190. And then my Y values, 5.88, 5.99, 5.74, 6.1, 7.47, 6.93, 6.42, and I got lost. 7.97, 7.92, 7.62, 6.89, and 7.9. All right, let's see what it looks like compared to the calculator. So I highlight the two columns. I go to Insert.
You have a work email.
I go to Stat Plot. Ooh, not much of a correlation there. And this is why it's so good to have technology. Right now, it doesn't look very, I'm saying probably 0.1 or 0.2, maybe. Let's see what they get. And highlight it and make it bigger. Somebody take the square root of 0.6503 for me. And what do you get for R factor? Raise 0.6503 to the 0.5 power. What do you get? That's all right. I'll just look it up here. No, we got something wrong. Something is wrong. I got something typed in wrong or something. What did y'all get for y'all's A on the calculator? Okay, that's all right. I'll find it myself.
Where's the list of numbers? Because I think one of the numbers is typed in wrong.
Thank you. All right, 35. Let me check where is my,
The
hold
third
on a minute.
number on the right, the third Y.
Hold on, I can't find my spreadsheet right now.
Okay.
I get aggravated. All right, so let me move this over. I only got so much to work with here. All right, 35, 50, 75, 95, 120, 130, 145, 155, 160, 175, 185, 7.9, 6.89, 7.62, 7.92, 7.97, 6.42, 6.93, 7.47, 6.1, There it is. 6.74.
Yeah, that's it.
Now let's see what I got. Is that what the calculator got? 0.1155? No. 0.0115. 0.01. Let me redo. Add trend line. Display R. There we go. Delete. That's why you got to watch those points. Is that better? Let me check because y'all ain't going to say anything. 0.0116 and 0.5973. That don't look like a 0.77 correlation. Very shallow. Maybe it's just the way I got it drawn. Maybe I need to go down like this. It still don't look like a very strong correlation, but you got a 0.77 correlation on the calculator. Everybody got it? Now, do y'all see how to do those now? So that's the type of question I would ask on a test. Any questions? I want to make sure. Everybody good? All right, let's go back to the PowerPoint. And there is your plot. Okay, I want you to write these down. These are standardized test questions. I showed you the 3 that I would do, but you need to also know nonlinear. Okay, there's your algebra parabola as well as your cubical function, but you need to know these are nonlinear. So write those 5 down so you'll have that for your standardized test. You can study that in your notes for your standardized test, whether it's the T's or the, whatever. So you got this one, you got this one, and you got this one. So you need to make sure you draw a cubic and a parabola and just call it nonlinear. All right? This is how you find R. I'm not even going, you can write it down, but I'm not even going to go into this. Let the calculator do it. This is some tedious math. I'm not going to make you do that. You're welcome. Again, you might want to write these down or just make sure if you ever have point straight line, that is called perfect positive. If you've got a strong correlation, a moderate, perfect negative, strong negative, moderate, none, and nonlinear. So you don't have to write all these down. You need to write down the words perfect, strong, and moderate. Perfect, strong, and moderate. Because there is a question on the test that has 4 choices: 0, perfect, moderate, and strong. And you have to match those up with the graph. I'm not talking too loud for the second floor, am I, Miss Gravina? Are they complaining?
No, this girl asked me if I went to high school with her.
I didn't know, because sometimes my voice carries like down the hallway. That's another reason I teach from home, because when I teach there, everybody can hear me.
No, I have my headphones in. Nobody can hear you but me.
Oh, you got your earphones on. Okay.
Yeah.
All right. That is a strong correlation right here. Strong correlation. And I'm not going to. There is your mathematics for doing the R factor. And there's no need to do that. I can either give you a short, give you 5 points and you do the R coefficient, or I can give you 10 points and you do it on the calculator. And I would much rather you do it on the calculator because you actually see it better than 5 points. You see what I'm saying? I can't give you 20 points like this or whatever this one is. I can't give you that on a test and expect you to do all this and give you 3 questions like that. I can't do it. Unless I give you 3 hours to take the test. And there is the R factor. I'm just looking to see where's another test question. I haven't seen another test question yet. So far, the first one we did on the first one we did looking at and then the drawings of the moderation and the correlation. That's the only test questions I've seen so far. Lurking, write this down. Write down lurking variable. And I'm going to give you an example, if I haven't already, what a lurking variable is. All right, you got lurking variable. A lurking variable is a variable that you have to think about. Let me give you an example. Here is an example of a test question, homework question, standardized test question. I want you to write this down because you will see this again. You've got 2 graphs. This is not like Con Air and suicide rates. This is drowning deaths in a 3-month period. And this is death by Rocky Mountain spotted fever in a 3-month period. Is there a causality? Is there a correlation? You know, both of them have correlation. One of them is 0.82. The other one is 0.92. There is correlation, but is there causality? Not necessarily, but there's a lurking variable. Does anybody have any idea what the lurking variable is? And I don't know if is lurking variable, is that with a LE or a AL? I think it's LE. Does anybody have any idea what the lurking variable is with drowning deaths and Rocky Mountain spotted fever?
Is it because they happen in the hot weather months?
How did you know that? Did you read that in the book?
No, I think we've gone over it before.
Okay, good. I can't remember when we went over it, but hot weather, that is a lurking variable. Make sure you make a note of that because that is a test question, not only on my test, but it's also on standardized tests. They like to ask these type questions. They'll give you 2 graphs and they'll say, do these have a lurking variable or do they have causality? Remember when I told you that half of probability and statistics is reading? Okay, and when I say reading, I also mean context and I also mean common sense. Sometimes you have to think about things like this. All right, now with the Nicolas Cage and the suicide, there's nothing that you could put with those 2, nothing. You can't even say, well, depressed people that usually commit suicide go watch Nicolas Cage movies. You can't link the 2 together by no means, okay? Period. You can't do it. But you can link these two if you think, if you think about it enough, you could find something, and that is hot weather months. Because nobody is going to go jump in Lake Hartwell unless they're raising money. Nobody's going to be dropping into Lake Hartwell at minus 15 degrees or 15 degrees. Nobody, unless they're raising money. Okay? So remember that. Lurking variable. Next. And I better shut up because I think when I'm coming to an end. Let's see. Now, could there be a lurking variable, bone mineral density versus colas? I have a brother-in-law, and he's technically my ex-brother-in-law, but he's still my brother-in-law because me and my sister married brother and sister. So, yeah, my ex-wife is my sister's husband's sister. So anyway, he drinks, this is no joke, he has a cooler beside his chair in his den. And he drinks, not diet drinks, he drinks sugar drinks. And he drinks about a half a case to a case a day. And he's got all kinds of problems. Does that have anything to do with the drinks that he's drinking? Yeah, because you could put a Coca-Cola in a piece of metal pan and it will eventually eat through the metal pan after a long period of time. All right. That stuff will, and I'm not saying I don't drink them. I drink them every once in a while, but I don't put a cooler beside my chair and drink a half a case to a case a day. I can't do that. But, bone mineral density versus colas consumed per week, I would say there's probably a lurking variable in there somewhere, or cause and effect. Common sense, context, use those two together. You have to think out of the box sometimes when you're talking about a lurking variable. There we go. You ever seen these movies? You ever seen these? Y'all ever seen these commercials on, what is it? OCPD or OC? It's the lung disease. What is it called? COPD. What do they not mention about most of those people that have COPD? They smoke Marlboro Reds for like 30 years. They never say that. Okay. My dad had COPD and he smoked for like 25 years. Finally, he quit after his first heart attack. All right. So, you do have lurking variables in there. Okay. There we go. See 4.2? What are we doing? What are we doing in 4.2? You're doing slope and you're doing point slope equation. So I'm going to stop with showing you what they're doing there. They're just finding the slope. I'm not doing these. Okay, you can forget that. We're not doing that. We might do some of that. I'll get to that later. So let's stop right there at 4.2. Any questions? Nobody's going to say anything, so I just